Hi everyone, welcome to my series on Galaxy for Bioinformatics. In today's tutorial, we are going to look at how to build a Galaxy workflow. So I will start with this workflow here. We are going to build a genome assembly and annotation workflow. This is the first episode in this particular series. I mean the genome assembly and annotation workflow building, right? So by the end of this tutorial, we are going to generate this workflow which is being shown right now. Now, if you're new to Galaxy and if you're also new to building Galaxy workflow, then I will encourage you to check my introductory video, which gives an overview of the Galaxy workflow system. So now let's go back to the Galaxy page and start the exercise. Okay, so we are on the Galaxy page now. So what you need to do first is to create an account and log in. Okay, so this will enable you to save whatever work that you do. So make sure to register and then just log in. All right, so if you don't know how to do that, I have a tutorial that shows how to do that. So check the description, you'll find that link and also use that to get your account. All right, so let's get started. So first of all, open your browser and then go to the Galaxy page. There's the link. I'll leave the link to this page in the description box. And then go to workflow. So click it, and then if this is the first time you are using that particular system, then there will be nothing here. So it says no workflows found. All right. So we are going to create it. So this workflow is very simple. So we are just going to chain some tools together and then perform our genome assembly and annotation. Of course, I'll also show you how to get an example data to test with. And you can also use your own data if you have. All right. So you just have to follow the instructions I'm going to give here. All right, so let's do this. So it says no workflow, so we need to create. So if you want to create a workflow, when you are here, when you've clicked and you are here in the workflow system, come to this side, create. So this will create a new workflow. So click it, and then when you click it, you have this comment. It says create workflow name or name workflow. All right, so we need to name it. All right, so let's do that now. So what you should note is that with workflow creation, it's not saved in your history. All right, so that is why I did not create any new history. It's saved in your account. So no matter the history you use, you can still import that workflow. All right, usually in my tutorials, I create a history, I name it, and then I start the exercise. But with workflows, you don't need to create any new history. Everything is saved in your account. All right, now let's name our workflow. So this is genome assembly and annotation. All right, I can also add some information here, maybe the workflow, let's say workflow that accepts past few reads and perform genome assembly and annotation. It's just an information that comes up when you open that workflow. All right, so let's create the workflow. So we'll click create to get it done for us. Okay, so we have that done. So you should make sure you check the name that you gave it to it. If the name that you gave is not what has appeared, you can just come to this side again and then just change it. All right, that's fine. So this is the name, so you can always edit it. All right, so now we are going to start. So this workflow is a genome assembly and annotation workflow. All right, so I'm going to keep it very simple because I assume some of you are beginners, and then later we can add up. So if you are going to perform your genome assembly, that's what we'll do first. Then you will need to get your input files. All right, so for it, we are going to use a paired end data. That's what we are going to use, but you can also, I mean, in principle, follow the same instructions and then modify it to suit your needs. If you have single end data, that's fine. Probably I'll make another tutorial where I show how to also design workflows for single end data. That's also okay. All right, so we will need to start with our inputs, our data inputs. So the tools are here. So on the left side, you will see inputs. All right, so just click it and then you'll find some additional options here. Now for it, we are going to use this one. We are going to say input datasets. All right, so I'll click it, and then when I click it, you have it here for being displayed for you. I repeat, when I click it, you will have the inputs dataset to being brought up for you. So you can place it anywhere you want. That's fine. I mean, we are following a particular order, so that's fine. So this is input. Now, because we are going to import a paired end data, we need to get 2 of the input data sets. So this is the first one. All right. So when you click it, you come to the attribute section and you give it a label. So since we are dealing with paired end, this will obviously be the forward width. So I'll just say Pascal forward width like this. You can add additional information here, but that's fine. I'll just leave it as it is. Or you can also say input Pascal width. Maybe I can say R1, or maybe 1, or etc. I mean, with the parent, some will give it underscore R1, some will say 1, some will say .1, etc. So you need to know the description for your data. All right. So I'm just putting something here for you to know what it is. All right. So that is it. So we are not going to do anything else here. Okay, it says format. That one I'll leave it. We are doing a basic workflow, so I'll leave this one here. When we start the complex ones, we will do further modifications. That will be another tutorial. Okay, so I have my notes here, which is done. And then this is the Pascal forward width. So you can see that the name has been reflected here. Now let's add another one because we are dealing with paired end. So we click input data sets, and then another one will be shown for you. So you can bring it, let it be in the same line. You align it, then you come to the right side and then you give it a label. So this will be Pascal reverse width. So here too, you can say input Pascal. Right? This is underscore R2 to etc. And it's just a description. All right. So once it's done, so you can click this one again to see what you did, and this one. Okay, I think I'll just make sure the names are the same, the annotations are the same. So there's input Pascal width. There's annotation. So I just want to make sure I am consistent here. Okay, I think everything is okay. Now let's just check. Yeah, so we have our input. So there's read 1, this is read 2. All right. So we have them. Let's add another thing. I repeat, we are done with the inputs. So let's add the other 2. So I will search for spades. That's what I'm going to use. So I'll say spades like this to give me the spades 2. Okay, so we have the assembly. So here we are going to select this one here, spades, genome assembler for genomes of regular and single cell products. So now single cell project, I repeat, this is for spades, genome assembly for genomes of regular and single cell projects. All right. So I'll click it and then space will be indicated here for me, to be shown here for me. So I'll bring it somewhere here. Now, what you should note is that if I don't know what Pascal rates, if they are the raw rates, then it's important to perform quality control. All right. So quality control involves assessing the quality of the data. It will also involve trimming and filtering of the reads where necessary. You will also want to maybe check contamination, etc. Okay, so those are things you can do. You can also add them in principle here, and then you can just continue. But for this tutorial, because I'm keeping it simple, I'm just looking at the core steps that are involved in genome assembly and annotation. All right, so you can modify this workflow and then add your quality control as well. So you can do fast QC, and then for trimming, you can use Geomatic, or you can also do Trim Galore. There are tools available that you can use, and of course, I'm tutorials on that. So just make sure to do that. Alternatively, if you also need help with building a workflow on Gallery, you can always book a session with me, and then we can work it out together. That's fine. Okay, so let's continue. So because the workflow is going to run in a particular order, we also need to direct that. So the input here, they will have to come into the space tool, then space will do its job. All right. Now let's come to the space itself. So when you click it, all right, because we are dealing with paired, then we need to make sure it is reflected here. All right, so at the moment we see FASTA/FASTQ files star, but what we want is for space to display an input for read 1 and an input for read 2. So after you have clicked the space tool, come to the right side and then you can edit the attributes. All right, so here let's first give it a label. It's important. So we say space assembler, and then you can give it any name you want. I repeat, you can give it any name you want. It's your workflow. So this is a time to experiment, and thankfully this is the Galaxy server, so you don't have to worry about your computer crashing or whatever. So don't worry, just go all out and then practice. All right, so annotation, a brief description. I'll say space assembly tool. That's fine. And then I'll scroll down. Now there are things that you may have to modify depending on your needs, but I'm just going to use the basic options. All right, so here with space you can perform both assembly and error correction. You can also perform only the assembly, or you can also do only the error correction. For this tutorial, we are going to use just the assembler. So I'll just select this one here. All right. Okay. Now, what you should note is that the difference between the workflow and the classical approach for running the tools is that with the workflow, you already kind of preset everything, you program everything, so you don't need to modify them again once you are running. So you do your settings, everything is done here, and then you proceed. Now, if you are to run space with the normal approach, then you have to select all these steps again and then do it. But with the workflow, once you do it and you save it, whenever you want to run it, you don't have to go back and modify. You can just run your stuff straight away, right? So that's the beauty of workflows. Okay, so let's proceed. So let's do this. We have selected this one. When we come to single end or paired end short reads, we are dealing with paired end. That's what we'll use. So I'll just click it. Now the paired end, we have paired end individual data sets. We have paired end interlaced. We have paired end list of data set pairs. Now for this tutorial, we are going to use just a single sample. So I'll go for paired end individual data sets like this. But if you have multiple samples, then it's advisable to use this one here, the list of dataset pairs. All right. If you have multiple samples and you're having a challenge, you can always contact me and then we can work something out. Okay, so take note of that. Now let me reselect my paired end individual datasets. All right. So once you select, you realize that the FASTA, FASTQ, FASTA, now we have two of them. One for read 1, one for read 2. All right. Now let's click again to change it. If you do it, yeah, it goes again. Okay, so I'll just go back to this one here. You should always be paying attention to your tools. Now let's scroll down. So I think for now that's it. The rest we'll use the default settings that comes with it, and then that's it. Okay, so now we are done. So when we come here, now we need to supply the inputs to space. So when you come to this one, the inputs, you have this and this. For each of them, you see this blue circle with this arrow in, or the greater than symbol. So just click it. Make sure your cursor is in that circle, and then you will see that the color has changed to green. Then you also have this coming up. Output is data set. All right. So make sure to click it and then hold it down and then drag. So you see a line, okay, being shown. So just pull that line and fit it into this one here, which is also green. Okay, so once it's fit, you will see that line moving from that side to this side. And that is done. Now we do same for the read 2. So you come here, you click it. When you click it, you see this line coming up or picking out. Then you can drag it, and drag it into the other side, which is the input. So here, these are inputs tools, but this is an output. So this output here is feeding here. This is the input. So this is an output and it's feeding to this input. So the output here is serving as an input for space. Okay. Now for these ones, I'll leave them. So these are the outputs that will be generated. We have them here. Okay. So here These are other options you can use. So if let's say you want to perform a hybrid assembly where you are combining both short reads and long reads, then you can also supply your long reads to this session. If you are using another Paul reads or PacBio or this or all those ones, then you can just add them here. So that's it. But here we are dealing with just short end reads, so you keep it that way. So these are the output that will be generated. All right. So these outputs, you have assembly graph, you also have a log, you also have contigs and then scaffolds. All right. So these are the output that will be generated. So these outputs here can serve as inputs to other tools, and I'll show you an example as we move along. Now, once you are done, you can always use your mouse, click on anywhere, and then just be dragging, and then you see that the interface is moving. So it's just a way for you to scroll and then get some new spaces. Okay. So now you can also zoom in and out. Okay, you can use your mouse to do that one. Then if let's say it's too small or too large, you can always do the zoom in and out. Okay, so take note of that. Now I'll just zoom in again. Let's see. Let me just. Okay, so I'll just zoom in to make it larger a bit. Let me try once again. Okay. Okay, perfect. So I'm here. Let me reduce it a bit again. It's too big for me. I think I'll do it from the browser here. Yeah, this should be fine. Okay. Okay, yeah, now we are here. Okay, so let's do this. Now we are done with our genome assembly, so we need to also add the annotation. All right. So with the annotation, let me just do it again. So with the annotation, we have tools we can use, and one of them is prokka. So I'm going to use prokka for the genome annotation. Okay, because the data I'm going to use is a bacterial isolate. So I'll come to this side, and then I'll search for prokka. So I'll search for prokka. So I'll just type prokka, and then it will be shown for me. Okay, so this is it. So we have prokka. It has been shown for me. So I'll just click it, and then you see that it has come somewhere here. So you have to always keep track of what is happening. So there's prokka. You can now move it to another side. Let me do it here. Let me check. I'll just move it somewhere here. It has to join the others. Let me enlarge it a bit. I have to send it to where the others are. Okay, so I have it here. Now I will zoom in a bit. Let's see. Yeah, this should be fine. Let me do it a bit extra. Okay, so this is it. I prefer to make it. Let me just do this. Yeah, let me gradually increase the size. Perfect. So this is fine. Okay, so I have the prokka also here. Now you should also note that after genome assembly, it's important to perform quality control. So you can use tools like Quast, which will perform some analysis, and then you can use those statistics to evaluate your genome assemblies. You can also use Busco to check the genome completeness. So these are things you have to do. All right. So for those ones too, I will cover them in another tutorial. This is an introductory video. So I'm going to make another tutorial where I go into details with the genome assembly annotation reference. Those ones I will specify, I will include the quality control steps as well. All right. So I repeat, make sure that if you are going to use this on your own data, you include the quality control steps, both initially, before the assembly, and then after the assembly, right? So take note of that. Okay, so let's proceed. So now I have the prokka here. So what I'll do is to supply prokka with some inputs. So here we are going to use the scaffold. So there's the context first aid, there's the scaffold. Now the space, when you check the space manual, it's recommended that we use the scaffolds for the downstream analysis. So that is what I'm going to. So that is here. So I'll just click, and I will drag it to this one here. All right. So that is it. Now with prokka, it also accepts trusted proteins that can use for annotation, but for this tutorial, we are not going to do that. We are going to just use the default settings. So this is the workflow. So this becomes our final workflow. Okay. Now these will be generated, and then when they are generated, one of them is going to serve us some inputs, and that is what we have linked here. All right. So with prokka 2, you have all these outputs. Now, description of these outputs, let me just enlarge it a bit. The description of these outputs can be found on the prokka GitHub page. I'll leave the link to that page in the description box. All right, so just take note of that. Let me make it a bit smaller. Let's see. Yeah, this should be fine. Okay. So this becomes the workflow. So it's final. We have our inputs, perform our genome assembly, then we also perform our genome annotation with prokka. So that is done. So once it's done, you can save the changes. So come to the right side, then you can save it. I will just zoom in a bit. I want it to be bigger. Yeah, so it's a bit bigger now. I'll just do this. Oh yeah, and you can also zoom in from here. You can see this side here. This you can use it to zoom in and out. So I'll just reduce it a bit. I should have shown you that one earlier. So you can just reduce it a bit here, or you can increase it. Yeah, or you can also use your mouse to do that. That's fine. Okay. So now let's come to the right side here. Okay. So with prokka, when you click it, you can also change the settings here. Okay. But what we are going to do is to add a label. So here is going to be prokka. Labels are always important so that you know where the tools are. The annotation, let's see, genome annotation. All right, so it's just a description. Now the settings here, you will leave them with their default parameters or default settings, and that's it. So if you're an advanced user, then you can also modify them to suit your needs. That's up to you. But for now, we'll keep it simple. So let's go over our workflow again. So we have our inputs. I click it. I'll check the label is there. We also have this one. That's for V2. We have space assembler. It is there. We have prokka. It is also there. Okay, so that's prokka. So now we are done. So what we can do is to save the changes. So come to the right side again, and then you will see this one here. Let me just enlarge it a bit. That will be better. Yeah. So when you come to the right side, you see these icons. Okay. So the second one, when you hover your mouse on it, it says save workflow. So this is how we will save our workflow, right? So just click on save, and then it is done. So it is now saving the workflow. So now we have saved it. Okay, so it's done. So once it's saved, that means we are ready to use the workflow. Okay, so let's open another Galaxy instance with our browser. So I'll just open a new one here. I have opened a new one. By the way, even here, once you have saved it, you can still click this one here, this Galaxy. So this will tell you to go to the home page. It may give this warning, but we have saved all the changes, so we don't have to worry. So you can go to leave page, and that will send you to the Galaxy home page. Okay, so that's fine. Okay, so now we are done. So now it's time to test the workflow, or let's say it's time to run the workflow. So if you want to run it, then this is where the history comes in. So you need to make sure you have named your history. So you can come to history, click on plus, then rename what will come up. Let's say genome assembly end annotation, and I will save it. Okay. Take note that this history here, this is different from the workflow. Let me just open the workflow here. Okay, this is different from the workflow, which is here. Okay, so we take note of that. Now, let's do this. So if you go to your workflow, you will see the workflow being displayed for you. And sometimes the name may change, like in this situation here. So if the name has changed, you can still come to this side. Let me just show you how to rename it. So just come to the workflow. On the left side, you see this arrow here. So click it. You have this drop down. You can edit. And then you can rename it here. Let me just rename it here. Then you can save it. Okay, so when you save it, this is still persistent. So there's a way to change it. Let's go again. And then let's do it here. So this arrow, just click it. And then there is this option here, rename. So you can click it. And then this will rename it. So you can just put the appropriate name there. So this one should be okay. Let's see. Okay, I think it's still persistent. Anyway, you have to reload the page first to see the changes. Okay, so if the change doesn't work, don't worry. You can probably, it's just a symbol, so I'll just rename it again. And then now I'll just remove the symbol. I think it's the end that is causing that. So I'll just say Genome assembly end annotation. I'll just say okay. So hopefully this one should work. All right, so it was the end symbol which was giving us the issue. So it's has been resolved. Okay, so now we are okay. So we'll use our history now. Okay, so now we have our history created. And so we need to run the workflow. And of course, before we run it, we need an example data. Okay, so with the data I'm going to use, it's here. It can be found here on the ENA database. This is the data. All right, I'll leave the link to this page in the description box. So what you have to do is to download this data to your PC and then re-upload. Ideally, we can import the data from the Galaxy platform here. We can import it here, but I want us to simulate a situation where we have our own data and we are going to upload to Galaxy server, and then we run our workflow. So I want you to first download this data sets and then use it. So use this one here. So to download, you can click it. And then when you click it, you'll be asked to save it. Okay, so you can just download it. So download for this and then this, both files. All right, so just do them. Okay, so for me, I have downloaded mine already. So these are my files. So I'm going to use them. Okay, if you have your own files too, perfect, you can also use that. That's fine. So let's get back to the Galaxy page. We have our history. So what we are going to do is to first upload our data. Okay, so to upload, I'll come to this side, upload data. So I'll just click it, and then I'm going to upload the file. So to upload the files, you can click on choose local files. So choose local files, right? So click it. And then you can select your files. All right, so you can select both files and then upload. Okay, so you can click it and then it will be uploaded for you. Alternatively, you can drag them. You can also drag them like this, and that will also be done for you. So any of them should be fine. And after getting your files registered here, you can click on Start. So click on Start, and once you click on Start, check the progress bar here. You should make sure it's 100%, and then you can close it. So let's wait for the progress to be 100%, and we can close this one. Okay, so once it's 100%, you can close this window and then check. So when you check the right side, you will see that Galaxy is preparing the files. And when everything is completely done, you will see that the background color will be green. So you should see something like this. So if you see something like this, that means that the data has been successfully uploaded. So now we can proceed with the testing of the workflow. So to run the workflow, you come to workflow. So you click it, and then you have the workflow display for you. So you come to the right side here, and then you click on run workflow. You can also come to this side, this arrow here, and then just view it first, download all those stuffs. But we are going to run it. So I'll come to the right side here and then click on run workflow. So I'll click it, and then when I click it, you have this coming up. Right. So when you have this coming up, then you have to select your input files. So you will see our label. Okay, this is the input dataset 1, input dataset 2, and we also have our annotation. So you see everything has been indicated here. You can also expand to full workflow form to see the rest. You can just click and see the options available here, then just decide what you want to do. But I'll leave everything because we have already made the settings. So all that I need to do is to supply the workflow with our input files. So with space, we will need the forward reads and the reverse reads. So this is the forward reads. So I have to make sure I select it. That's R1. And then the reverse, that's R2. I have to make sure I click and select it R2. So you should always pay attention to these things. So once it's done, you can click on run workflow. So let's click on the run workflow and then wait for everything to get done for us. So click it, and then that's it. So now what we have to do is to wait for everything to get done for us. So you also see the progress here, and then the outputs will also be shown here for you. So let's wait for everything to get done for us. Okay, the workflow has executed successfully. So you can view the reports. So come to view reports, right click it, and then go to open link in new tab. So when you do that, another tab will be opened, and when you click on that tab, the workflow execution summary will be displayed for you. So this is the workflow execution summary. So we have data sets, we have workflow outputs, we also have a test set. So you can read the test here as well. Now let's take a look at the data sets. All right, so we have a data set here. So here we see this error message. It says error, internal server error 500. This error message, I suspect, has got to do with some of the services running in the Galaxy platform. All right. So this error here has got nothing to do with our data set. I checked the data set and everything looks fine. Okay, so take note of that. But if you're using your own data, then I will encourage you to check the data and make sure everything is okay. You can also post this error message in one of the Galaxy forums. There are forums that discuss Galaxy topics. You can post the error message there and then get a feedback from experts. Okay, so they will tell you what is happening. Okay, so just make sure to do that. But so far, the data looks good. The outputs are also fine. Okay, so that's it. You can also check this one here. So generate PDF. So you can right click and go to open link in new tab. So when you do that, that's what happens. Let's just check that tab. You have a PDF created for you. So this has the reports. All right, so we see the reports here. So it tells you the step and annotation. All right, so we have step pascal forward reads inputs, this pascal reverse reads, space assembler, prokka. So that's basically the workflow that we use. Okay. Now let's get back to this page here. So we have the outputs here. These are the outputs. All right. So space will generate 4 outputs. We have them here. And then prokka also generates about 12. Let's say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yeah, 12 outputs. A description of each of these output files can be found on the prokka GitHub page. So I'll leave the link to that page in the discussion box. All right. So this is how we do it. Okay. So after performing your annotation, you can also visualize the annotation using JBrowse. There are things that you can do after you have generated your outputs for the annotation. Okay, so these are things that I've covered in our tutorial. So you're looking for more tutorials on bacterial genome analysis, then I will encourage you to check the playlist right here. Also, if you're looking for more tutorials on Galaxy, this playlist here will also give you more tutorials on that. So I will see you in the next session.